this activity, students will learn how jiggling molecules transfer heat to each other and how insulation can slow this process down. Students can perform this activity within small groups or as a class activity between groups. Students will examine how insulation affects how quickly a bottle of hot water cools down by comparing bottles with different types of insulation. Instructions for how this activity could be performed as a scientific investigation can be found as an appendix in the lesson plan. Provide each group with 3 uniform water bottles and 3 thermometers. For each group, 1 bottle will be left bare as a control, and the 2 others will be covered in different kinds of insulating materials. Suitable materials could include paper, cardboard, neoprene fabric, or any similar material. Encourage students to use their own jumpers or scarves and make the connection that these types of clothes are used to keep people warm in winter because they are good insulators. Students should wrap their selected material around the water bottles and secure them using rubber bands or tape. If you are running this activity as a competition, each group will only need 1 water bottle, and the teacher can make measurements for the uninsulated control bottle. Once the bottles are ready, carefully pour an equal amount of 60-degree water into each bottle, filling to about half full. You may want to use a funnel for this. You can prepare 60-degree water by combining equal parts of freshly boiled water and cool tap water, or by using a thermometer and adding boiling water to tap water until you reach 60 degrees. For safety reasons, don't use water any hotter than 60 degrees. Students should then place their thermometers in the bottles, measure the initial temperature of each bottle, and start their timers, recording the temperature of each bottle every 10 minutes over the course of an hour. Encourage each group to draw dot plots of how the temperature in their bottles changed over time. An example of what you might expect can be seen on screen. Within groups, or as a class, discuss which bottles stayed hottest the longest and why. So why does insulation cause the bottles to cool down more slowly? Heat escapes the bottle when the rapidly jiggling molecules of water bump into the more slowly jiggling molecules of the cooler surrounding air and give away tiny packets of heat energy called phonons. In insulating materials, it's difficult for phonons to move through them, so by wrapping the bottles in insulation, we slow down how quickly the phonons of heat escape the bottle, and thus slow down how quickly the bottle cools.